Welcome to The Explainer. So today we're looking at literally our most valuable resource, right? Time. Specifically, all that time we spend trying to cram information into our brains. I was actually shocked to learn recently that we might be wasting hundreds of hours on study habits that frankly do almost nothing for our memory. It's wild. Let's look at the cognitive science together and rank the most popular study techniques on a tier list, going all the way from the absolute basement F tier to the elite S tier. We're going to learn how to climb the tiers of cognitive effort so we can study smarter, not just longer.
Okay, I've got a question for you to kick things off. Think about the techniques you rely on right now. Are your study habits secretly F tier? I know it's a hard truth to face, but the most popular methods used by students and professionals all over the world are often the absolute worst when you actually put them under the microscope of learning science. We kind of hold on to these techniques like safety blankets, mostly because they feel good. And hey, maybe because we just bought a really expensive pack of neon markers. But feeling productive and actually retaining knowledge? Yeah, those are two very different things.
So this massive gap between what we think works and what actually works really comes down to this contrast. We have the illusion of learning, which happens when a technique requires very little mental effort. It creates this high familiarity, meaning you recognize the material, which completely tricks your brain into thinking you've learned it. But contrast that with true learning. Learning is a biological process, guys. It requires high cognitive effort to build durable memory. Think of it like lifting heavy weights at the gym to build physical strength. If the mental weight isn't heavy enough, your brain just isn't getting any stronger.
All right, let's dive right into this. Act 1, the illusion of competence, the F tier. This is the bottom of the barrel, where unfortunately most of us end up spending the majority of our time. First up, in the F tier, we've got highlighting and rereading. Decades of research show that highlighting is, well, practically useless for actual learning. Its only real utility is helping you find key words later on. And rereading, it really isn't much better. It gives you a marginal memory effect at absolute best. So why are they F tier? Simple. They're just too easy. They don't force you to connect ideas or evaluate concepts. You're just sweeping your eyes or a neon marker over a page, which creates that dangerous false familiarity we were just talking about. Honestly, if you throw away your highlighter today, you might automatically become a more efficient learner just because you're forced to try something else.
Moving right along to Act 2, the recall trap, the mid-tier.
Now we're moving up into the mid-tier, where we finally start doing a little bit of heavy lifting. Let's look at an absolute classic, Cornell notes. I see this as a solid C-tier stepping stone. It's the OG viral note-taking method, dividing your page into 3 sections: questions, reference notes, and a summary. It's a fantastic structure for beginners because it introduces those deeper levels of thinking. But here's the catch. Most people execute it totally incorrectly. They write superficial questions, take verbatim notes, and just editorialize a few sentences for a summary instead of truly synthesizing the information. Now, I found this next concept incredibly fascinating: semantic priming. This is exactly what those questions in Cornell notes are actually supposed to do. Semantic priming means deliberately asking thoughtful, complex questions that prepare your brain to make connections and build knowledge schemas. If you aren't asking deep questions that force ideas to connect, you aren't priming your brain. And at that point, your notes just become a really neat, clean, but ultimately totally ineffective piece of paper. Okay, let's jump up to the B tier and weigh our active recall methods. First up, we've got blurting, which is basically a trendy rebrand of the brain dump. You read a topic, hide it, and just write down every single thing you remember. It's free recall, meaning it requires high active effort. Then we have flashcards, often digitized in apps like Anki. This uses cued recall paired with a spacing algorithm, so you're testing yourself just as you're about to forget the information. Both of these are solid B-tier methods because they force your brain to actively retrieve information. They genuinely make you work for it. So why do these hit a B-tier ceiling? Why aren't they higher? Well, because blurting and flashcards are fantastic for memorizing isolated facts. If you're a medical student who needs to rote memorize drug dosages, flashcards are absolutely perfect. But they are terrible for teaching you how to solve complex problems. They just don't force you to evaluate how one idea influences another. It's like you're memorizing all the individual puzzle pieces, but you aren't learning how to put the whole puzzle together.
Which brings us to Act 3, the S-tier masters.
Now we're talking about the absolute pinnacle of cognitive science. If you want deep, flexible, and truly robust understanding, these are the techniques you've got to adopt. To understand the S tier, we first have to talk about schema building. This right here is the absolute secret to high-quality memory. Schema building is the process of creating networks and connected bodies of information. It's all about seeing the big picture, evaluating how important each idea is compared to the others, and understanding how everything fits together cohesively. This is the exact biological mechanism your brain uses to store high-quality, durable memory. Average studying ignores this. S-tier mastery totally revolves around it. Our first elite method is the Feynman Technique, coming in at a very strong A tier. The steps are simple, but man, are they incredibly demanding. Step 1, learn complex material. Step 2, try to teach or explain it to a complete beginner, like, say, a 10-year-old. Step 3, remove all the jargon and simplify your explanation. The reason this works so phenomenally well is that it forces you to think through the narrative and logic of the topic. You have to make executive decisions about what is genuinely important. And that is a highly sophisticated level of brain processing. So you might be wondering, why is the traditional Feynman technique only A tier? Well, because it's limited by your own expertise. If you're a beginner teaching a beginner, it's pretty tough to know if your simplified explanation is actually accurate. You have no feedback. But that's where we add the missing link, AI. It turns out if you explain a complex topic to an AI and ask it to grade your accuracy and evaluate your logic, you instantly fix that feedback problem. An AI-assisted Feynman technique shoots straight up to S tier. It's a total game changer.
Before we jump into our next S-tier method, I want you to chew on this quote for a second. It's easier to clean your house with the lights on rather than with your eyes closed. When you try to build schemas for complex topics entirely in your head, it feels confusing and completely overwhelming. It is literally exactly like trying to organize a messy room in the pitch dark. You need a way to turn the lights on and externalize all that mental disorganization so you can actually fix it.
And that brings us to S-tier mind mapping. Now, a quick caveat. Most people do this terribly, and it ends up being a D-tier strategy for them. But when executed with strict technique, mind mapping is unparalleled. Mind mapping perfectly mirrors how the human brain biologically stores memory, which is in connections. It completely forces you to deliberately compare ideas against each other, visually evaluate their hierarchy, and weave everything into a cohesive big picture. It takes immense mental effort to declutter your thoughts this way, but that effort is exactly what translates into deep, robust memory. All right, final section, Act 4, the ultimate hack. Okay, so what if there was a biological cheat code that could basically maximize the efficiency of all these S-tier methods we just talked about? Let's talk about interleaving. Now, classical interleaving is when you alternate totally different subjects in one session, like, say, doing 30 minutes of biology, then switching to 30 minutes of chemistry. It's highly evidence-based and a super solid B-tier strategy. But advanced interleaving, that takes us straight to the S-tier. Instead of switching subjects, you stay within the same subject, but challenge the exact same concepts from completely different angles and perspectives. You mix and match confusing, related concepts side by side.
When you test similar, easily confused ideas right next to each other, your brain is absolutely forced to differentiate them. It naturally begins to see the sharp edges of where one concept ends and another begins. This makes it just unbelievably efficient for instantly spotting gaps in your knowledge, simply because you are deliberately challenging your brain in unfamiliar ways.
Well, we've definitely covered a lot of ground today in this explainer, going from the comfortable illusions of highlighting and rereading, all the way up to the cognitive heavy lifting of mind mapping, AI-assisted Feynman, and advanced interleaving. As we wrap this up, I really want to leave you with one final thought. True learning is biologically demanding. It's supposed to feel hard. So when you sit down for your next session, will you choose what's easy or will you choose what actually works? Thanks for exploring this with me, guys, and I'll see you in the next explainer.